The Digital Enablers for Natural Capital is one of 4 topic hubs within the Scottish Forum on Natural Capital, and its focus is on contributing to an enabling environment for natural capital in Scotland through exploration and knowledge sharing around nature technologies. This is the inaugural network event for that hub. It's not quite the first, though, because we did have a session a couple of weeks ago with CivTech, where we were exploring potential challenges for the CivTech programme that the Scottish Government provide. But this particular session is the first network event that's fully and properly about the Digital Enablers Hub itself. Probably also worth saying that we did kick off the Digital Enablers Hub with a survey, and the results of that survey is available on the Basecamp platform, which forms the platform where people can come together around the Digital Enablers group. Key findings are available also in a link, which I think, Julia, you can share as well in the chat, hopefully. Quite clearly, for a couple of things that were quite striking from that survey was the need for transparency in interpretation and verification around nature technologies, the longevity of platforms, and then also addressing human factors such as the uncertainty of value of the nature technologies to decision makers. So there's quite a few things that came out of that survey, which hopefully will be useful information for you. I'd now like to just mention that this is the 1-hour session, and we have 2 tools that we'll be showcasing and 2 speakers speaking for them. And I would like to introduce my colleague Philippa Viganó from NatureScot, who's NatureScot's Innovative Technologies Program Manager, great title, who will be introducing today's topic and speakers. And also Julia, who is in the background and is providing technical support today and is the coordinator of the Scottish Forum on Natural Capital. So if I could now pass over to Philippa.
Thanks very much, Ruchir. What a great introduction. Yep, so my name is Philippa Viganó, and as Ruchir said, I'm the Innovative Technologies Programme Manager at NatureScot, Scotland's nature agency, and we work to improve our natural environment and inspire everyone to care about nature. So I'm really pleased to be able to introduce the talks on these tools today. They both empower more people to take nature into consideration when they're making decisions. And I'm really incredibly proud to say that I've worked with Space Intelligence and D-Time, who are going to talk about these tools, on the development of both of these tools. So I feel very privileged to have been able to do that. We often hear about how important open data is for decision-making, transparency, how it can enable efficiencies and promote innovation, helping to facilitate the creation of better products and services. To really unlock the power of open data, we need to make sure it's findable by anyone using simple search terms and without having to know, who created it or where it's published. Detective by D-Time, which powers the new find.data.gov.scot site, does exactly that. It helps users to find data and helps data providers to gain insights about how their data is being searched for and used. And we've got Gautam here today from D-Time, who is going to tell us more about this tool. Before that, we'll hear from Paula at Space Intelligence about the Scottish land cover maps. Produced by Space Intelligence in partnership with NatureScot, they're a huge part of the data jigsaw that we need to help lots of different people and stakeholders to consider nature in their decision making. These are national maps of Scotland's habitats and land cover at a really powerful level of detail. They use field survey data to help train the algorithms that classify the satellite data, and each habitat class has a confidence figure so that we can use that data intelligently. Because the maps use Earth observation data, they're repeatable, so with the right validation, we can begin to see and understand change. And really important, the data is open for use by anyone. So that's definitely enough for me. I'll hand over to Paula now, and there'll be time for questions after both of the talks. Thank you.
Thank you, Philippa. Great presentation. Let me see if I can share my screen. I'm going to share some slides. Yeah, can you all see my slides now?
Yes, we can.
Yeah. So as Philippa was saying, yeah, I'm Paula Nieto. I work as head of mapping and carbon science at Space Intelligence. And I'm going to talk about the work we've been doing together with NatureScot, mapping the land cover over Scotland. So yeah, I'm basically going to introduce how we went from satellite data, what you have on the left right now, to producing a nationwide map of Scotland over 3 years with 28 classes. I will go in detail in how we created this, but here you can see already one of the challenges of mapping Scotland using satellites, and that's clouds, which, as you can see, even for today, if you are in Edinburgh, it's a very cloudy day, so this is a challenge for us. But actually, for me personally, it's been a great experience to be involved in this project because, as you may guess from my accent, I'm not from Scotland, but I've been living here for almost 10 years. So this project has given me the opportunity to investigate more into all the habitats that Scotland has. So a bit about space intelligence, what we do. We support nature-based solutions projects worldwide with the highest quality nature mapping data. So we use satellite data and machine learning to provide mapping, mainly of land cover and carbon maps. We work with different types of organizations. We work with one of the world's largest companies, but also work with forest carbon project developers, governments, and NGOs. Space Intelligence was founded in 2008, so it's quite new, but we have already mapped 1.5 billion hectares over 35 countries. And this is some of the companies we are working with and NGOs. A bit more who we are. Our founders that are Ed Mitchard and Marie Collins have more than 30 years experience in forest assessment using satellite data and are leaders in the industry. Now we've been growing. When we started with Philippa, this project, the company was like 6 to 8 people, and now we are more than 50 employees. Our senior team has published more than 100 scientific papers, and we have around 12 PhD qualified staff. So we proud ourselves that we are doing all this mapping based on the best possible scientific knowledge that we have. And we have people from multiple backgrounds, remote sensing, but also ecology, physics, engineering. This is a bit the process how we do our maps. So we've used large amounts of satellite data and field data with machine learning algorithms. The input data, as I mentioned, is remote sensing. You use training data from local experts, but also our ecological knowledge. And then we use machine learning. And these are our main products. So we do canopy cover, habitat mapping, carbon stock, and we also do changes between them. But I might just go into detail in land cover mapping because this is what we have done for Scotland. So we do this with our own product that is called Habitat Mapper. And this allows us to produce highly accurate maps of land cover over time for any type of ecosystem. We do these maps between the spatial resolution of 20 to 30 meters. The algorithm is supported and trained by local experts and our ecologists. And this allows us to customize the land cover classes. So we not only go from forest to non-forest, we can customize the classes depending on the project, the client needs, and the type of habitats that we are mapping. We have mapped smaller areas like project areas, but we have also go to big areas, countries. And our maps are highly accurate. And we normally tend to achieve an accuracy of more than 90% overall accuracy. And this is some of our data inputs. So we use a combination, as I mentioned, of training data, optical and radar data from remote sensing from satellites. What is the difference between these two types of data is that optical data uses the sun. So it's more or less what a satellite sees, like taking a photograph of a human eye will see from space. And this has problems because it's impacted by clouds and you cannot take images at night, for example. So we use that with a combination with radar, and radar uses a microwave sensor, and this allows us to penetrate in the clouds, take images at night, and see more 3D images and other special conditions like water, etc. A bit about what we did this. So Scotland has set a very ambitious goal of being net zero by 2045, sorry, 2045. This will need to stop the carbon emissions from multiple sources, and land use is one of the major drivers. So improving the land management will allow the Scottish Government to meet these emissions targets, and also additionally to improve biodiversity conservation. There was also a need to measure performance for the Natural Capital Index. So NatureScot came to us because there was this information gap. There was a need to have highly accurate land cover maps over the whole of Scotland every year. So it was also possible to assess change. And this is what we did. We partnered with NatureScot in 2021 to develop the country first ever nationwide high resolution habitat map. In that moment, we did the land cover maps for 2019 and 2020, but then now recently we have also added 2022, and that allows us to also see the changes between those years. We have mapped in total 28 land cover classes. This follows the UNIS land cover classification. We did level 1 UNIS classification and level 2. The first habitat maps have a bit fewer classes. I don't know if it was 24 or something like that. I don't remember right now. But with the 2022 map, thanks to the feedback we got from NatureScot, we improved our maps. We managed to add some new classes. I will go into more detail later. In total, we mapped 7.5 million hectares, or 200 million pixels. Each pixel have a meter of has a resolution of 20 meters, so it's a 20 by 20 meter size, or a 0.05 hectares. As I was saying, we work very closely with NatureScot and their habitat specialist, together with our ecological knowledge. Also, when we finish a draft of the maps, this was sent to receive some feedback, and we did an update recently of the maps. They have high accuracy. We reach around more than 90% for the level 1 UNIS classification, and I think more than 85% for the level 2. And they are all available by a public bespoke website and are available to download. I will provide a link. And they can be also provided in the chat, maybe for anyone if they can access, if they want to access them. Yeah, and these maps are totally open. Anyone can download them and use them. Here I have an example, including in the slides, an example of the land cover map in, this is near Loch Lomond. So the blue water you can see is part of Loch Lomond, and how we use images from different sources. So Sentinel-2 is an optical sensor and Allos Pulsar is a radar sensor. So that's why you see the difference between them. We also use images at different times of the year because this allows us to map better different habitats due to the characteristics. Some habitats have some phenology or seasonality. So we are able to map them better by looking at different times of the year. So this is an image in the left of the spring and the same area in autumn. As I was saying, radar sensors allow us to see the land a bit different. So in this image, for example, that is black and white, you can see more darker areas is water or bare areas, and lighter areas are forest or vegetation. Here I have a quick demo. Let me see if I can. This is the web page where you can visualize the land cover maps from Space Intelligence. I hope it's working properly. But you have a legend in the right where you can see things as the local authorities areas or national parks. So now it's zooming into Cairngorms, and you can see the different land covers. It has the data for the 2022, 2020, and 2019 map. So now if it's going to 5, where you can see all the oranges, those represent mainly agriculture. And you can switch between the different maps. And here, yeah, you can see change. So this is a data set that expresses changes. So all the yellow is changes that is gone from to agriculture, but you can also see deforestation or regrowth. I will go into that a bit later. Here is some information about how we did the maps. We collected a lot of training and validation points. In the left, you have the image. Each red dot was one of our training or validation points we collected. So in total, there were more than 18,000 points in the whole of Scotland, or 1.45 million pixels. And as I was saying, we mapped 28 land cover classes. Level 1 is in the left and level 2 is in the right. This might be too small to see, but you also have the links so you can access the maps and see more in detail. And I will go to some examples. This is a change, some of the change we observe. So the land cover change allows us to see specific areas, what has happened there. So in here, for example, is focusing in 2 areas in the north and in the south, where we can see in red some deforestation, but we can also detect other things like forest growth or urban development. And yeah, some of the key findings. We found that raised and blanket bogs cover the majority of the area. They cover 16.5% of the country, or 1.32 million hectares. These blanket bogs are crucial for peat formation, and peat is really important because it acts as a significant carbon sink, and it's vital for climate regulation and biodiversity. It's also very important as a habitat for many species that live in Scotland. And in here you have an example of an area in the highlands where you can see all the reddish colors are peat bogs. As I was saying, we also added some extra classes in the 2022 map. And one of the classes we added was windblown. This was especially important after the storms that happened in 2021, like the storm Erwin. Scotland was heavily hit by storms, and there was a lot of trees that were just windblown by the storm. This we consider is unintentional deforestation. So instead of mapping it as normal deforestation, this is not intentional. So we try to separate this in our land cover maps, so we can just create a class to quantify how much the forest was affected by this. So we did this, and we detected over 27,000 hectares of windblown trees in Scotland. And this is an example of one of the areas. As you can see in the images, most of this forest was hit by the storm. And in the lighter gray, well, medium gray is all the area that we consider was windblown. Another of the key findings, it was we managed to map native Scots pine woodland. This was also an additional class we added in the 2022. So in general, the most common forest classes we found were highly artificial coniferous plantations and broad-leaved deciduous woodland. But due to the importance of the Scots pine woodland in Scotland, we added these new classes that allow us to identify the few remaining areas of Scots pine. And we detected around 20,600 hectares of Scots pine woodland, which is quite smaller than what we saw were highly artificial coniferous plantations. That is like almost 500,000. And this can help organizations focus their efforts in the regeneration of this important ecosystem. Another finding, we also improved the classes we were detecting in coastal ecosystems, and we managed to add classes to detect ecosystems such as littoral sediments, sand, maher, shingle, and coastal rock. Personally, I love this class because I didn't know even the existence of maher before. And when I arrived in Scotland, and then when I started working in this, I managed to do some trips to the Outer Hebrides. So this is a photo with the land cover map of Barra. And as I could visit the maher and all these ecosystems. And yes, how to access these maps. We have the platform to view the maps online. That's the one I just quickly show in the video. And this is the address you can link. You can also download the data files from the Spatial Hub of the Government of Scotland. And additionally, if anyone requires any other information or is interested in mapping other areas or extra years, please get in touch with us. And yeah, thank you very much for having me in the webinar. And yeah, if anyone has any questions.
Thanks very much, Paula. That's a very impressive technology and quite a lot you've done since 2019. If anybody would like to ask questions, please do put your hands up, and also feel free to put a question in the chat as well, and I'll monitor that and pass questions through to Paula. So one question that's already come through: can this technology assess habitat conditions?
So it can detect habitat conditions in the sense of we can detect different types of habitats with these 28 classes. The project didn't include going into more detail of the condition of a specific habitat. Some of them can be done with remote sensing. Some of theirs are not possible, but this was not done for this specific project.
Just to follow up on that one, how much of this, given how much AI technology has changed since 2019, how much of this are you now doing even more through those kind of machine learning approaches rather than manually? Or has there ever been a manual component to the mapping that you've done?
So there is always a manual component in the sense that we have ecologists collecting all these samples I show with the red dots all around Scotland. And we do that for every country because we need to actually see what type of habitats are there to be able to train the model. So there is always the manual component. You can only trust the machine learning with it. We just need to know a bit more about the information, and we always have to do some research into the dry season, the phenology, just to see what type of input data from the satellites can help us improve the map. And we did this as a very iterative process with Nature Scotland, where we were always talking to their experts to receive feedback about the maps we were creating and to improve them.
Thanks very much. Yeah, there's an interesting question from Jaburi that's come through. Something I was also wondering about as well, which is how is the data ownership managed? You know, is the data, you know, you've obviously kind of got this available through your website openly. How do you manage licensing and access? How, you know, in terms of openness, and any challenges around that for you?
So the data is completely open and it's provided by the Scotland government in one of the links I provided, so it can be downloaded and used freely. I guess there are some license limitation to acknowledging NatureScot and space intelligence, but it's completely open.
It's quite unusual as well, isn't it? Because like if you look at some of the other map providers historically, they've all had it in quite very, you know, tight licensing, not as open as this. So it's quite
it's been a great project by the Scottish government and NatureScot that has allowed us to make this open. And we know of many use cases with this has been used by multiple companies, but also NGOs and scientists, PhD students. So yes, I totally support open data. I think it's great. And I feel like these products are helping a lot.
Great, okay. I've got another question that's come through from James. Actually, James, do you want to read this one out, or would you prefer me to kind of read it out for you? I'm just wondering, it seems to be just my voice at the moment. Do you want to come in? Are you okay to do that, or do you want me to read it out for you?
No, I can read it. Yeah, can you hear me okay?
Yep.
Yeah, no, I was just curious about how the process that you've used may affect how well kind of linear habitats are picked up, mainly to do with the resolution. So features such as riparian woodland or indeed maca as well. Is that likely to be missed by the kind of 30 or 20 meter resolution, or is that still managed to be captured in most cases?
So we manage, because the resolution is quite good, it's 20 meters, we managed to capture quite a lot of the mosaic of the landscapes. But yes, we will only capture what is there in like this 20 by 20 meters. If there is some variation within that pixel, then we will just see what we think is the majority of the class, because we need to assign a class to that pixel. What we have produced as well is not only a map of the main class we think is present in each pixel, but also the second closest possibility as well. And that was provided to Nature Scotland.
Brilliant, thank you. Lindsay, I notice your hand is still up. Did you want to follow up on your original question?
Yeah, thanks. Yes, I did actually. Just to and thanks very much, Philippa. It was a very interesting presentation. It's really inspiring to see these things happen. It's going back to habitat condition, and it very much relates to the development of biodiversity net gain and also biodiversity credits and metrics. And habitat condition is essential to the calculation of both those elements. So again, I'm just wondering to what extent you think the evolution of this tech will be able to answer these questions, or will it take another 5-10 years before it can accurately give habitat condition assessments?
Well, I think this product can really help prioritize assessments, and I think very interesting for to achieving those is having the change. So having the change between the years can let us prioritize areas for the biodiversity conservation and other types of management, where you can see what change has been happening. So I don't know if that answered your question properly. It will be very interesting to continue this further. We've done a bit of research into more detailed mapping of peatlands, for example, including depth of peatlands and things like that. So this can be taken further into more detailed quality of the habitat classes. But yes, this project just was funded to do the habitat maps at this stage.
Thanks very much, Paula. Yeah, it sounds like some habitats might be possible to do it more easily than others from what you're saying there, but it's good to know.
Great. Okay, can I just check actually, Paula? I mean, I think we've got no hands up. Just interesting, the Digital Enablers Hub, which is kind of like hosting this event. Do you see space intelligence getting value from that for the work that you're doing here? And if so, what kind of value do you think you would be getting?
Yeah, it's a good question. So all this data, I think, sometimes is available down there, but maybe so people don't have or don't know this data exists and can be very useful for their use cases. So I think these kind of tools where data just can reach more people are great, so that everyone can use it. That is, as I said, is open source, and the same for other products that we can create, that we can put it open. Then we have other products. Of course, we are, as a Space Intelligence, we are a company. So other products that we produce are for to make some gains out of it. So we cannot share them openly. But also, if people are interested, we can also always work with different researchers and organizations to produce more maps.
Brilliant. So it's a collaboration.
We are hoping to extend this to England as well.
Right. Got you. Brilliant. Well, thank you very much, Paula. I'm going to move on now to Gautam. Just straight over to you, and you can introduce yourself.
Thank you.
Gautam, we can't hear you. I don't know if you're just preparing or if you're on mute.
Yeah, there you go. I hope you can hear me now.
Yes. Yes.
Great, and I hope you can see my screen as well.
Yes.
Perfect, yeah. Hi all, my name is Gautam. I'm the CEO founder from DTime. I gained most of my data AI experience in the renewable energy sector. When Paula was presenting the land cover maps, it kind of took me back a few years when I was myself doing such analysis, looking for bioenergy potential and solar energy potential in different landscapes. So thanks for that great presentation, Paula. And thanks again for this opportunity to present here, Ruchir, Julia, and thanks for the excellent introduction, Philippa. And thanks to everyone who's joined here. Getting to the presentation here, I'm going to talk about Detective. It's a tool that we developed through the CIPTEC program, and we are discovering hidden data sets using AI. Now, just to be sure we are on the same page here, when I say data set, what I refer to is a data resource, and this can be a CSV file, a PDF file, or a text file which can contain data, plus the metadata that describes what the file is about and who owns the file, etc. So when I say metadata, think of all the fields like title, descriptions, ownership, published on, updated on, timestamps, and all that. Now, this is not a standard approach to categorizing metadata, but if you look at it, different data sets that are published on different websites have a range of metadata. It can start from non-existent. So all you see is the title of the file name perhaps, and absolutely no description about what that file is and what data is contained in the file. Then you can find sparse data sets, sparse metadata levels, intermediate metadata levels, and occasionally complete metadata levels. And this is purely based on the number of fields that are usually populated. Then there are metadata standards. An example is schema.org. What this does is this helps identify what datasets are available on a website. So imagine you're thinking of Google as a search engine that will help you find different shops, but Google doesn't tell you what specific things are being sold in the shop, for example. Similarly, if you look at a website which contains data, all Google is telling you at the moment is that this website contains some data, but doesn't talk about what specific data sets that they have. So schema.org and standards like this will help Google detect the specific data sets published by the organizations, similar to how that analogy was bringing here, where you can identify what objects are being sold in a shop. This is what a metadata standard like schema.org does. Google has a dedicated dataset search engine that I will demonstrate in a bit. And this is what they use to detect datasets on websites. Now, if you look at this quadrant here, and I'm calling it the dataset discoverability quadrant, on x-axis, you have got the metadata levels from non-existent to sparse to complete. And on y-axis, you got the standards. Either it's present or absent. So when it comes to large-scale search engines like Google, particularly their dataset search engine, they are focusing more on the quadrant where the metadata level is good, as well as where there are metadata standards available. And as you can see, there's plenty of vacuum here in the quadrant, which Google Dataset Search is not addressing. From what we know, they've already indexed over 45 million datasets across the world. And imagine the scale of datasets that are not being indexed at the moment. So the problem here is people presume that Google is detecting all the data for them, but they're not necessarily doing that. So unless you know the source of a dataset, you won't necessarily find it. And in the earlier example where Paula mentioned about space intelligence owning datasets, now you know about it, but earlier probably you didn't know about it. And that's the case with many other data sources as well. So we need a search engine that will help people, bump onto those datasets and then use it. Now, what we developed is Detective, as well as the Scottish government branded version, which is find.data.gov.scot. We are looking at this quadrant where, even if the metadata standard is absent, we are still able to find the data. And then when we index it on the search engine, we attach certain standards to that. So what that means is you can find the data through Detective or find.data.gov.scot, or because we are attaching standards, Google will potentially detect the data sets through us. So we are, in a way, complementing Google Dataset Search here. Now, on the other side of the quadrant where metadata levels is absolutely non-existent, we are also generating metadata or enhancing metadata using the latest AI technologies that are available. If you're interested, we can talk more about it later. But what I want to highlight here is the fact that the vacuum that you saw earlier is what we are filling through Detective and Find.data. Now, from our research in Scotland, we saw that only less than 30% of data source websites like Public Health Scotland, NatureScot, Canmore, etc., are being detected by large search engines like Google, because not everyone follows metadata standards, or the metadata levels may be not sufficient. Because of this, what happens is data users like data analysts, data researchers, or policymakers spend a lot of time searching for data, and time is money for their organizations as well. And on the other end, there are these data providers who are sitting there hoping that their data sets are being discovered. And they're sitting in the dark with access to no insights on who's using their data, what they're doing with the data, what impact the data sets are creating on them, etc. So Detective is an AI-powered dataset search engine where we are agnostic to how datasets are published. And this idea of surface web and deep web is something I should clarify. So surface web is that part of the web that existing search engines have indexed. And deep web is not dark web, for clarity. It is that part of the web which is not being indexed by search engines. So we are agnostic to how data is published, and we look both into deep web and surface web. And what that means is we are able to help make datasets more discoverable regardless of how they're published. And the solution, as I said, was developed through the CIPTEC program over the last 2.5 years. Currently, in terms of volume of datasets, we believe we are the largest dataset search engine for Scotland. And as I said, Detective is available through find.data.gov. And at the core, it's an API because we didn't want to build yet another search engine. What we wanted was a solution that will make data more discoverable. Hence, most of the focus was on the API. And this API can be integrated to any website that you are familiar with. For instance, NatureScot is a website that you're familiar with, and you can simply have access to wider dataset search through this API. And this is something we are planning to do eventually as part of a roadmap. That means you will bump onto the datasets from wherever you are. In a way, datasets are at your fingertips. Now, let's do a quick demo here, and I'll come back to the slide. So that's the Google dataset search engine that I'm talking about, which probably some of you have used in the past. Probably some of you may not have come across it. But if I'm doing a quick search for natural capital Scotland, and I'm using this keyword Scotland here, just so that we focus our search on Scotland, you can see 9 datasets coming from websites like ONS, gov.uk, ONS again, and a few. So from here, you can find the dataset, the data resource that you want. In this example, I don't see the data file link, and the descriptions are not sufficient either. And that's the case with most data. So yeah, in this case, there's a data file here that you can download from the source. It's good because it's doing a global search here. Of course, it's Google. Now, if you do the same search on Detective, and that's the Detective website, as well as you can do the same search on find.data.gov.scot as well. It's powered by the same search API. So if I do the search for natural capital Scotland here, you can see 78 results coming from the last time I counted, it was around 17 sources like Care Inspectorate, Edinburgh Data Share, etc. And then if you click on any of you can filter out the files from here based on the format. So let's say we are interested in a GeoJSON file, maybe more interesting for you, for those who are working with spatial data, etc. So here you can see the title, the descriptions, and a few other interesting functionalities. You can download the file directly from here. That said, we are not storing any files. We are simply signposting you to the source. So here you can do a preview of the spatial files to take a decision, whether if this is the right data for you. This one is a big file, so probably it's not opening. Yeah, it's taking a little longer. Anyways, I will encourage you to play around with the tool to have a look at different data sets that are available. And then again, because we are not just targeting data users here, we are also helping data providers. So as a data user, you can provide feedback to data providers about the use cases you have, the data quality aspects, etc. And in addition, for each data set, we are also algorithmically measuring the quality of metadata, and we are compiling use cases and download metrics, etc. Now, in addition to all that, we are also aggregating these data sets across topics. And currently we have like 80 topics, and then aggregating them across data providers. So if Edinburgh Data Share is one of the data provider, then you can have a look at all their data sets through a dedicated page for the data provider from here. And then you can look at all the insights in an aggregated fashion. So you can look at all the data set, metadata quality of all their data sets here. And on an average, they've got like 4 out of 5, which is pretty good from what we have seen. You can look at different use cases, so what people have used their data sets for. And you can find the search terms that people have used to find the data sets of this particular organization. Again, where the downloads happen from, when it happened, who downloaded the data, etc. These features might be of more interest to the data provider organization, particularly, insights and being able to generate reports about the insights, etc. Similar to how you looked at the data provider page, you can also see topics. So currently, as I said, we've got 80 topics, out of which I just searched for nature, and I can see natural resources as one topic. And then under the topic, we've got like 238 data sets. So these are all algorithmically categorized, and you can see different data sets coming from different sources here. And then again, you can see insights about the metadata quality. So on an average, for a topic like natural resource, the metadata quality is 3.5 out of 5. And you can see the search terms used, etc., etc. So you get the gist of it. Let me now come back to my presentation mode. So what I showed you was a comparison between a detective and Google dataset search. And as you saw, you're able to find more data for Scotland, and we only have data for Scotland right now. We are in the process of scaling up geographically as well as vertically. So there is an particular interest in environmental data as well. So in addition to the data discoverability problem that we're solving, as you saw, we are also enhancing the metadata. We are able to provide more information about the data so that a user can make a better decision about what is most relevant to them. Plus, we are generating insights about metadata quality and usage. Now, one question to you is, as a user, what topics might you be interested in? And this is Slido's presentation. So if you could scan this barcode on your phone and suggest a few topics that you would like to see on Detective that we can use, we will be happy to implement it as we go forward. Because at the moment, as you saw, natural resources is possibly the only topic under the nature category, but you could think of many other topics that you might be interested in. So feel free to make a few suggestions and we can see them popping up here. And I'm aware of the time as well, so this is the last slide and open to questions as well while I leave this open here.
Brilliant. Okay, so yeah, feel free to go into slido.com and give some input back to Gautam if you have a chance. We have got a few questions in the chat as well. Just first one from Lindsay, just double checking that it's free to use. I think it is, but can you confirm that it's available for the public? Yeah, absolutely. So the discoverability aspect is free. If you create an account, you can unlock a few more features. Because we want to sustain the product and help scale it up, there is a commercial model around it, and most of the commercial aspects are around insights. So if you're an organization, whether you're a data user or a provider organization, you might want to subscribe to some of the paid plans to access those insights. And that makes sense, doesn't it? Because this is a CivTech initiative originally, yeah, which a commercial aspect was part of the requirement, wasn't it? Yeah, absolutely. One of the requirements was to be able to commercialize, and it's not easy to commercialize open data. And we didn't want to close the discoverability aspect either, because we want people to be able to discover data. That's a big problem we're solving here. So we had to find a work around it, which is where you can search for any data. There's no limit to how much you can search. If you want to download a preview file, then you can create a free account. Again, you don't need to pay. You only pay if you want to access additional insights. And at this stage, we are more keen on gathering more feedback from users, like if they're happy with what they're finding, if they've got any feedback, feel free to use the forms at the top to provide us feedback. And it's great that data providers can get some value as well, which helps to justify then the data providers like public sector organizations investing and making the data sets available this way. Another question that's come through is, are you collecting data sets beyond the environmental sector as well at the moment? Or yeah, absolutely. Yeah. So when we started developing the solution, there was a focus on environmental and health data. But as we moved forward, we realized that there is more value in being domain agnostic.
because not every project is focused on a single domain as such. There will be interdisciplinary projects, and we want to be that one-stop shop for all open, commercial, and even internal data search. I didn't talk much about the internal search aspect, but there is something which we are exploring now where we can help organizations with internal search problems also leverage detective technology. But for now, what I'm showing here is the public search engine, which will be used to find open and paid or commercial datasets.
Great. And there's a question from Alice here. Would it be possible to share what the underlying AI model is and what it is trained on?
Yeah, briefly. So this is where our core IP is as well, that we believe our USP here is in the way we are onboarding the data. So when it comes to open data, like the one from improvement service is an interesting example. So they got plenty of data, but all the data files or data resources are sitting behind a login wall. So all we have access to is the metadata. So what we're doing is we're scraping the metadata in a way that we then use it to index the metadata on our search engine. So when you're searching for something related to spatial, we do a matching of that keyword with the metadata that we indexed. But here again, it's not a keyword only matching, it's more of a semantic matching approach where we match that word spatial with all related words so that you find more datasets through that. In addition to that, we are using AI in the way we onboard data. And we are also experimenting how we can embed, large language models into this process to increase the speed of onboarding data and reduce the cost. So once we hit a point where the cost is insignificant, then we can easily scale this up globally, and you will be able to find more data sets across the world through Detective.
Thanks. Yeah, Alice, did you want to follow up at all on that?
Yeah, I was interested just to know if there was a kind of, sorry, I'll turn my camera on. Interested to know what the kind of underlying model was, whether it was like OpenAI or Llama 2 or one of those, or is it something that you've developed yourselves?
Yeah, so we haven't developed any LLMs ourselves. We didn't feel the need to do that yet. So we are only using existing models, but there's a bit of flexibility here because it's plug and play for us. We started with OpenAI because we got some credits as a startup to use that, but we have also been experimenting with the open source models like and all that. So yeah, it's pretty flexible at the moment. It's plug and play for us, if that answers the question. In the future, we don't know yet that there might be a need where we would want to fine tune some of the models for our requirements, but we are not there yet.
And there's a couple of questions from Pete. Pete, do you want to actually speak on this one?
Hi. Yeah, you kind of answered the first question, I think, but I was wondering how deployable the platform is, like at different scales. So could an organization use it internally, potentially?
Yeah. So how this works is if you look at the spectrum of data, and let me just show you the slide here. Yeah. So if you look at the spectrum here of public to closed data sets, there are existing enterprise search engines out there. What they don't have is a lack of focus on insights or the capability to generate metadata, for example. So if your organization has data in different servers or systems, it's kind of scattered around, and you would want to quantify how much of data you have, and then be able to attach a discovery element to that, helping people within the organization find the data that they're looking for, and then add a permissions layer as well, because not everyone has access to all the files within the organization. That all can be done using this technology. And the good thing here is, unlike existing solutions, we are able to attach open and paid dataset search to that closed or internal data search. So what we have is like that single universal platform through which users within the organization can find datasets. So it saves a lot of time that currently they are spending on finding data from different sources. In addition to that, just to highlight the fact that we're not just a search engine, we believe we are more of a discovery engine, which means we are not just doing search, but we are also providing insights. And then we are adding this capability to analyze data as well, which some of you might be familiar with ChatGPT code interpreter. So we're trying to add that as a layer on top of search engine so that you find the data, you do a basic analysis, and it saves you a lot of time.
Brilliant. Well, there are some existing, particularly in the marine space, data sets out there, and I think there's a question from Janet about Janet. It might be worth just if you're okay to do this, just to say a little bit about Medine, as well as ask you a question if that's all right. Sorry, we can't hear you. There might be an audio issue. No, we still can't hear you. It's okay. I can read out your question. So essentially, does this system link to Medine, which is a marine environmental data and information network, which is an initiative to work together to improve access to and stewardship of marine data?
Not yet. Is that what it is? Sorry.
Yeah, probably not the wrapper.
Yeah. Yeah, not yet. As long as it's so as long as the metadata is available. So regardless of whether it's open, commercial, or closed data, as long as the metadata is available somewhere, that's all we need to make that data sets discoverable. So we're a signposting solution, and we don't store any files. All we're doing is we're helping people find where the data is. If the data is open, directly downloadable, then you can download it from Detective directly. Otherwise, you can go to the source and download it from there or access it from there.
Can you hear me now?
Yes, we can. Perfect.
Brilliant. Okay. So yeah, I was saying thank you very much. And I think it was a really wonderful reminder at the beginning to talk about the importance of metadata. Certainly in MEDIN, which is the Marine Information Data Network, is about, there's an enormous importance and emphasis on this, the metadata. And what we're trying to do within SEPA is encourage the freshwater folk to use the same patterns and system for the metadata and how we classify that, because there's an awful lot of stuff that we're trying to link upstream and downstream stuff. It's that whole thing about connecting the data so we can actually do this analysis. Really interesting. Thank you very much. And I really hope get a chance to play with this at some point.
Great. Yeah, that's really wonderful. And what I usually do, and what I would encourage you to do, is if you bump onto any sources like that, please go to the data source registration form here and submit that source here, because that's our starting point to then go and look at the site. If the site uses certain, so we have different ways of onboarding data. If it uses certain approaches, then it might be very quick for us. For instance, if the site is built using CCAN, which is a data publication data management system, then it's a matter of a couple of hours for us to onboard the data, to be honest. And that's the capability we have achieved over the last 2.5 years. So we're getting better at the speed at which we are able to onboard data. So hopefully you'll start seeing more and more data sets. But for now, all you have is data for Scotland.
I take it you offer free credits from the commercial model for people that submit data links for you as well, yeah?
Free credits in the sense, so we just request you to sign in for free and then provide the link to the data sources.
For entering links.
Yeah, that could be something. Like, we are also exploring gamification approaches to see, what will encourage users to provide feedback, and that feedback is very valuable to a data provider to make more relevant data sets available in the future. So we are exploring those possibilities.
Absolutely, yeah. So we're coming towards the end of the webinar. I'd like to thank Gautam, and I'd also like to thank Paula and Philippa, and also like to thank Julia. But can I just check if anybody's got any general reflections or comments that they feel they would like to put in, which might not fit very well in the Q&A sessions, but if there's any general comments, please feel free to put your hand up. We've got a couple of minutes if you have any questions, sorry, any reflections. Or you can put some comments in the chat. Just while I'm waiting for that, just to say that we do have a series of events that we're planning, and there will be another webinar in the summer. It's still currently being finalized, and Julia is going to post more information about it on the Basecamp for the Digital Enablers. So please, if you haven't had a chance yet to browse through the Digital Enablers hub, please do so. And I think Julia's will be sharing a link to that for you as well. Anyone want to come in? Any reflections? No? Okay. Well, in that case, I would like to thank all of you for participating in this session. I'd be very keen for you to carry on some of these conversations within the Basecamp forum itself as well. There is an opportunity there for building new collaborations off the back of the insights that we gain as we have these webinars, and new projects as well. And the CivTech have reached out to us, as they have done with Gautam's project. They're also interested in new initiatives that they could fund as well. So thank you again, and look forward to seeing you all on the network.
Thank you all.
Thank you.
Thank you.
Thank you. Bye.